So we're back to talk about the Anoma Local Domain.
Thanks. Right, so it'll be fun to talk about this. So I'm hoping by the end of the presentation you'll understand what it is, why it exists, and some of the API and functionality that it involves. So we have the Anoma symbol, which represents the controllers being interacted with by users, computer systems, things like that. So why does it exist? I want to talk about this before we talk about what it is, because we can understand what it is by understanding what it's trying to accomplish. So we want to make it easier for developers to interact with our Anoma controllers. We want to help people utilize Anomas, especially developers. And I want these applications to be able to access data that we derive from the interactions that we have with given controllers. It could be any controller really, but like we're mainly concerned chiefly with Anoma controllers, and they should have scoped and conditional access. So we're not necessarily talking about like an individual user, but we could be talking about many users with their own like role and permissions hierarchy. But we want this all to be interacted within a single system. These applications should be capable of interacting with each other. There should be some persistent state. We would like the applications to be able to build off each other, right? So we want them to be interacting. And our applications should be good. Very vague term, but what do we mean by that? We have a certain opinionated ethos about what an operating system, for example, should look like. It should be possible to live edit the system, so you should be able to not have to take it down and retake it up. You should be able to debug it. It should be fault tolerant, so it should scale pretty well. It should, in many cases, not have assume like a one-to-one relationship, but many to many. And it should be object-oriented. Why object-oriented? Because we think it's the best way to develop protocols. And we also want this approach to be intuitive, comprehensible, and user-friendly. So what exactly is it? The way I would define the Anoma Local Domain is it's an operating system that acts as a trust zone for Anoma-derived data and applications. So usually in the controller, there's some global consensus that has to be achieved, but the local domain can simply say, by my own rules, I'm allowed to have this state, and it will simply do it. It can work as a private sandbox, and it doesn't need to hold consensus state. In fact, it can just derive any of that from like the API with the Anoma controller. It should be like designed for, and it should have like some pre-baked in applications, core applications, or anything that the user decides to create that are good for interacting with various external controllers. So the Anoma controller, as we've discussed, it could be like a database, it could be some other API, such that it can receive and process events. In other words, it's everything that's related to the Anoma protocol that is not specifically part of the Anoma protocol. So one way that we like to describe it is with the court and the chamber. So you have a court on the left where decisions are made about legislation. And so when you have like the chamber, you simply decide certain things. You make certain, you simply cast out these decisions in a sovereign manner, whereas the courts you need to go to the court, you need to say, can I make this decision? Am I allowed to? And the court may uphold it or reject it. In another way of explaining it, we have this diagram. So there's this red line in the middle. We have the local domain on the left and the controller on the right. The controller has its consensus state, which it gets from transactions that are being submitted. The local domain can have read-only transactions, which it then derives state from, and then it can compute on that data arbitrarily. It can also do things like run provers, and it has this thing that we're calling scry, which is a given API for interacting with states and applications, which we'll get to in a sec. The minimal requirements for what we would call like something like a local domain is it must have a key space storage. So currently we're using ETS, but it'll be backed by something like RocksDB later. It must have like a sensible and intuitive DSL for defining paths where you can find the information that you're storing, a handler registry, which holds dispatch information for those paths, the scry paths, which again, we'll talk about the functionality of that in a second, and the implementation of that functionality, as well as a place for event handling to live. So we have gem server processes for this. Luckily, we're using the Beam in the first instance because it's a nice virtual machine. So what is the scry API? So we have a similar API to Urbit. Suppose we have a path that looks like a file path. So this is what I mean by like intuitive. It's very similar to something like an operating system file path. Each word in this path could be understood to refer to an object. So the owner is an object, right? So it might have certain features, but it also has a functionality. Scry, it has a certain scry functionality. So you can see down here, there's like a handler registry, which describes functions that are reached by certain paths. So owner is like a path object, and it acts on the subpath via its scry function. So if you reach the owner scry function, it will receive the rest of the subpath, and it will know what to do with it. And all of these are objects, so it could pass it along, it could combine things together, and compose scry functionality together. And you might write applications as follows. So suppose I have a factory application, it's called factory, and what this does is it stores some function. So we'll get to an example in a second. It stores some function, and it's got this defscribe, this macro that describes how the functionality should work. So suppose you have this subpath, it will match this subpath, and it will scry the API handler, which is stored to receive the function, and then it applies it to its parameters, which are derived from these. So we talked about having a path DSL. This is similar to Peter Norvig's DSL for pathing and arguments that you might have seen in the past. It's quite intuitive. I think it's, many people have seen it, and it's very obvious what it means, I think. So the exclamation mark means like, bind this to a variable, bind variable to the name method, and params is the rest of the path. So here's an example of the use of factory. So we have a factorial API handler. So what this is actually doing, as you can see, it's actually calling scry. So this function actually calls scry once it's been retrieved and applied upon. So you store this, and you call it down here. You get 5. You'll get the factorial of 5, which is 120 or something like that. So that's the bootstrap functionality. The core applications, the things that you will need to actually interact with Anoma, and what we think are the vital components of the local domain for you to be writing applications and having a working operating system, are you need the application registry, which we've talked about. We also want prover dispatch, so you want to be able to construct proofs on your side. This is an important part of the process. You want subscription management for your event broker, and the event broker we have is actually a little different to other event brokers. We'll talk about that in a moment. You want a transaction builder because you need to be able to send transactions to your controller. You want key and identity management. Like we've said, we've tried in as many instances as possible to keep things agnostic in terms of scale. We don't want to assume one-to-one, so we want some kind of key and identity management internally so that you can decide, I want my applications to have some kind of role-level access. And there are also API surfaces. So like if you want to set up a JSON API, you should be able to do that. Other library functionality, indexer listeners. So if you want to, if you have an indexer, you need to read and derive data from it. You should be able to do that, as well as telemetry. More is definitely going to come as we go. So as I said, we have a slightly different event broker to most services. So in most services, you subscribe to a topic, you get all of the events from that topic. For our local domain event broker, you define filter functions, and the filter functions are sent to the controller, and it pre-filters them for you. So this is different to most services, but I think it's quite nice because you don't have to do the work of filtering it all out for yourself. And just a little bit more on the inspiration ethos and why we're doing it like this. I mentioned earlier we have strong opinions about why we want it to be like this. For example, with Scry, it's more similar to operating system file paths, so that's quite something that people can understand. It can be interrogated live. It's referentially transparent, and we think this will work well as a personal computing environment, as well as any application you want to build. We think Scry is just a generally good API for this use case. And in this way, the local domains, inspired by work like from Xerox PARC, from GT, these are like very good operating systems that you can look up. You can do all kinds of things. They were very successful. We don't currently have Anoma Level, which I realize I haven't explained. So Anoma Levels, we want to build a sort of virtual machine that the local domain will eventually use. So currently we're utilizing macros and hacking together Elixir to produce the local domain. But in the future, we would like to have something like Anoma Level, which can do this in a more natural way. But for now, we're trying to bring the ideas from Anoma Level into Elixir, so that you can do things like defining certain properties of the system declaratively. One thing that we often have to tell ourselves is you want things to be as many as possible, which requires a lot of forethought. So you can't just assume I've got like some controller out there. You might be interacting with many controllers. And as I said, you might have many roles within the system of the local domain. You might have many indexers that you're working with, many provers. So we try not to make assumptions about this because we don't want to conflate infrastructure provisioning decisions with protocol trust. And we're hoping to be held to account on this problem. So if you ever see us conflating infrastructure provisioning with the protocols, please let us know. But the Beam is very nice for this sort of thing since it's very good for building distributed systems. And that's it. Thank you for listening. Are there any questions?
Thank you, Jamie, for that presentation on the local domain. Any questions?
Hi, thank you for the lovely talk. I have 3 questions. Can I ask all 3 and then you can decide which
Go for it.
So number 1, when can I download a version of this that will replace Ubuntu? When can I use this as an OS on my computer? That's question number 1. Question number 2, I hadn't seen this idea of a file path as essentially a function applied to arguments. So if I have /var / and all of these, what gets passed to the top thing? Is it a string of objects, or is it the result of the object application after the first /? I hope that makes sense.
It's a list of objects. A list
It is a list of
because it
objects.
preserves the ordering.
So the first thing gets past the rest of the list.
That's right.
Was this your idea, or does it?
No, this is not my idea. This is from Urbit, and Ray has matured the idea.
This is from Urbit. Okay, thank you. I think that was only 2 questions, but...
The other question was, when will you replace Ubuntu with the system? I mean, it's a long way off, I think, from being in that situation, but obviously that depends on your use cases.
Well, there was a sentence in the slide saying we think this would make a nice personal computing environment.
Yeah, I mean, personal computing environment doesn't mean it has to replace your other operating environments, right? We don't necessarily think that it involves taking over the world. It just means...
Sorry, I didn't mean to put words in your mouth. I've remembered the 3rd question. In Unix, the fundamental abstraction is everything's a file.
Mm-hmm.
What is a fundamental abstraction here, please?
Everything is an object.
Yeah. Okay, thank you.
Hey, thanks. I also agree it was a great talk. 2 questions. The one just informs the second. The event broker as a notion, does that strictly live in the local domain, or is that something that lives across local domain and the controllers that it interacts with?
I think it lives across them, am I right? Yeah, the controller also uses it because it needs to be able to...
Okay,
to
got it.
receive.
So then my actual question then, so you mentioned like the need to like cater for like many interactions, and I got your example there for a particular local domain interacting with multiple
Yeah.
controllers. But when you say many, like there, I guess you also mean like multiple, and that's why I asked the first question, multiple event brokers that live within one local domain interacting with others. What would that look like, and why would that be
Well,
instead of one?
So I could give an example of what multiple event brokers living within a local domain look like. Maybe not the event broker, but for example, in the indexer, we're receiving from a GraphQL API, which is a subscription API, so that you're just passively receiving events. And you might also have this along with the event broker that interacts with the Anoma controller.
Got it. But like, would you ever have a context where you have multiple event brokers that interact with the same controller?
I haven't thought about this. I don't really understand why you would want to have multiple event brokers. Maybe Ray can step in here and.
Usually you have one event.
Yeah.
Usually you have one event broker
Yeah.
at every physical or logical location, and because you are relying on, you can pass it in a filtering function, which is either arbitrary code if you're like part of our code base, or if you're just some external consumer, it's some pattern that gets matched against. But either way, right, you having it's not something that you bifurcate, because it's something that you instead use the ability to filter to winnow down to receiving exactly the messages that you want.
Okay, thanks. To me, that sounds still more like one-to-many, just because it's instantiating a different broker for every other controller it interacts with. But
I mean, it's an application within the local domain in this case. I mean, I know it lives across, but it also lives. So it lives in the Anoma controller as well. But in this case, it's something internal to the local domain. So it's not, when we talk about many-to-many, we're talking about across network boundaries.
right. Okay. Thank you.
Any other questions? Yes, Tobias.
Quick one. You mentioned on non-slide application registry. Can you
Sorry, could you repeat
the
that?
application registry you
The
mentioned?
application registry.
Can you spend 2 sentences on what that is and what it
Yeah,
does?
so that's just some administrative application where you can manage your applications that exist within the local domain. So, for example,
Essentially,
I might say, I've got this prover hooked up to my local domain. I've got this prover hooked up to my local domain. Can you list all of the provers that are hooked up to my local domain?
Yes, or maybe there's a new fantastic decentralized application out there on the market, and you want to use that one. You kind of have to have some local representation of how you interact with that thing, right?
Exactly.
Fantastic. Thank you.
All right, let's give it up one more time for Jamie.